This is a very important question. See this. Which of the following lattices is not distributive? So what is a distributive lattice? A lattice in which the distributive law holds good is distributive, right? So first of all, I already told you something. If a lattice is distributive, then definitely there will be at most one complement for any element. But if you see this lattice, for the element A, B and C both are going to act as complements, so definitely it is not distributive, we know that, but I am going to prove it here. And similarly, if you see C, B and A both are complements, therefore we get two complements for an element, so both of them should not be distributive by the rule I told you earlier, right? And anyway I am going to prove it now. So see this. So what is distributive? It should follow distributive law. So let's take this diagram 1 and 2. Okay, so for the practical reasons, for the explanation purpose, all the textbooks they use this notation. They call it as L1 star and they call it as L2 star because these are important diagrams. So these lattices have importance for the later purpose. I'll tell you what it is, but just follow this convention. So this particular lattice is generally represented by L1 star. So this particular lattice is generally represented by L2 star. So later when I talk about L1 star and L2 star, you should recollect that they represent these two. Okay, now let's talk about L1 star. In L1 star, let's see whether the distributive law is holding true or not. What is the distributive law? So R should be distributed over, and for any three elements this should be followed, equal to A or B and A or C. So let's try to see whether it is holding true or not. I am not writing that it is equal. I am just trying to see whether this one is right or not, whether this particular equality holds or not on L1, right? So now what is A and C? It is nothing but meet of A and C, or the greatest lower bound of B and C, right? So for B and C, the greatest lower bound is B and C is X. So here it is X. Are you able to see this? For B and C, the lower bound is X. Now A or X. Now what does it mean? For A and X, what is the least upper bound? For A and X, since they are related directly, the least upper bound is A. Therefore the LHS, this entire part, it boils down to A. Now let's look at the RHS. For A and B, what is the least upper bound? For A and B, the least upper bound is Y. And for A and C, what is the least upper bound? For A and C, the least upper bound is also Y, isn't it? For A and B, the least upper bound is Y. For B, A and C, for A and C also the least upper bound is Y. And now if you take the greatest lower bound of the Y and Y, it is of course Y, right? So LHS is equal to A and RHS is equal to Y. So this equality, it failed, which means this particular law is not holding good on this lattice, and since it is not obeying the distributive law, it is definitely not the distributive matrix. Got it? So the inherent reason, the reason why it failed is because A is having two lattices, two complements, and because of that we are getting something like this, right? So the reason is this: since B and C both are complements, when I take the join, both are going to give me the same element, which is nothing but the upper bound Y, and then when I take AND, it is going to give me Y. Got it? That is the reason. Now here also you can see the same thing going on. See this? In L2 star, let me check whether this distributive law is following or not. I'm not sure, so that is why I'm putting the question mark there. B now see this. What is B and C? So this one, meet of B and C. So B and C are going to meet at X. So this part is going to be X. Now what is join of A and Y, A and X? join of A and X is clearly A. Therefore, the left hand side it is going to be A. What about the RHS? Now, in RHS, A or B, which means join of A and B, join of A and B is going to be B itself. Since A and B are related, the join is going to be B itself. And what about join of A and C? The join of A and C, A is here and B, C is here. Since both are complements, they are going to join at Y. So it is Y. And what is meet of B and Y? So B is here and Y is here. Meet is definitely, since both are related, meet is definitely the lower one, which means B. Got it? So since left hand side is A and RHS is B, right? So they are not equal. So even in L2 star also, you can see that clearly distributive law doesn't hold, and so it is not distributive. So one interesting thing is, if you can find any lattice in which either L1 star or L2 star is present as a sublattice. Okay, understand this. If you have a big lattice in which these two, either L1 star or L2 star is present as a sublattice, then you can say that that particular lattice is not a distributive lattice. In case if these two are not present as sublattices, then definitely that lattice is distributive lattice. Got it? So a lattice fails to be distributive. So when you can find out that for a particular element, for one element, if you see more than one complements, or other way of checking is, if you can see either this one L2 star or L1 star as the sublattices of some lattice, then you can say that even that particular lattice is also not going to be a distributive lattice. That is why these two structures are important. Remember them. L1 star and L2 star are important because if they are present inside any other lattice, even that lattice will fail to be distributive. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.